Okay, so we are now going to look at data types. Let's just do it this way. So I have data types. Okay, so for data types, when you are programming, you supply all kinds of information. All right, so whatever you supply, they have been grouped into categories based on their characteristics or properties. All right, so that's where data types comes in. Okay, so the data types simply means that the information you have, they have different characteristics. And because they have different characteristics, they have been categorized into what you call data types. So you should know these data types and know when to use them, how to use them, and then where to use them, because each of these can be used for in specific situations. So it's important to know them, and then we can proceed. So we will start with the first one, which is numeric data types. Okay, it's numeric. So we have it like this. So with numeric, I'll give two examples here. I'll simply say numeric integer. Okay, let me just do the label here. That's even better. So the first type, I'll say numeric integer, whereby that one, these are integers. Okay, for example, 10 is 1. Okay, 10 is a numeric data type, but it's an integer. Okay, that's what we have here. Now, if you really want to check the data type, you can say class. Let's say numeric integer. Let's look at the class and to give you numeric. Okay, so we have numeric integer. We also have numeric float. These are all numeric data types, by the way, but I have added the integer and float as extra descriptions. All right, but they are all numeric. So if I say 1.2, okay, that's a float, but it's still numeric. If I say class numeric float, I still get numeric. Okay, so you can also convert one to the other. If it's in float, you can convert to integer. If it's integer, you can convert to float. But this is something that we are going to do in detail later on. For now, just know that we have a data type called numeric. So numeric, your numbers can be integers or floats. There are other data types as well, but we are looking at the common ones. Later on, we can discuss about other ones. So I'll take you through a lot of them, at least those ones that will help you get started when it comes to programming. Okay, so let's proceed. Now let's also take a look at characters. I repeat, the next data type we are going to look at is characters. Okay, so here, if you've learned other programming languages, then what you should note is that in our characters, we can also say they are more like strings. Okay, in other programming languages like Python, and we call it strings. Okay, so for those who don't know Python, I also have a playlist for Python. So if you want to learn Python, just check the description. There's a playlist for Python for beginners as well. So characters, we put everything in quotes. Okay, I'm going to show you an example, so you don't have to worry. Earlier on, we did this. We said DNA, seq, and we gave some nucleotides in double quotes. I'm using another group of nucleotides here. So this is a character. Okay, or let's say character because we have several of them. So let's execute this. Then I can say class DNA seq. Okay, so this is character, the data type character. It doesn't have to be multiple, it can even be a single one. So if I say, let's say nucleotide equals A, it's still a character. Okay, so I can say class nucleotide and I'll get character. So it can be 1, it can be 2, it can be 3 more. So far as they are in single quotes like this or double quotes like this, they are data type character. I repeat, so far as they are in single quotes or double quotes, like what I have here, they are characters. All right, they have the character data type. Okay, to put it that way. So this is for the character. Now with characters like we have here, or let's say strings if I'm translating to other programming languages, you can also do manipulations, right? That is why we have to install this first. Okay, so if you have not installed this package, please install, because we are going to use that here, right? So take note of that. With numeric, we can also do our computations, but we will do that in another session, okay, later on the video. For characters, let's look at them, because we are bioinformaticians, we are biologists, we deal with, some of us deal with nucleotide sequences, so it's important to know how to manipulate some of these information in R. So for example, if you have your DNA sequence, you may want to check the length. It's a character. So with characters, if you want to check how many characters are there in that variable, you can just say nchar. Let's say nchar, you can say DNA-seq. This will give you the number. It's 8. When we count 1, 2, 3, 4, 5, 6, 7, 8. It's 8. That's why we have it as 8 here. Right. Now you can assign the whole operation to a variable. So you can say seq length, and you say nchar DNA-seq. So now if I print seq length, I have 8. All right, so it's very, very simple and straightforward. Okay. So that's for the character. Since we are dealing with sequence, you can also add. Okay, you can add as well. So let's say you want to add, let's say concatenated, or let's say the new seq. Okay, new seq. Let's say we are adding. Okay, we just have to say paste 0. So we have the current sequence plus the new one. Let's see, All right, so let's execute it, and then let's run. So when you run it, we have the new sequence. All right, what is that? Because we added, we concatenated it. Okay, this concatenation. So we can also do that. Now let's look at another thing. Now, if you are dealing with nucleotides, let's say the sequences, one of the things that you may want to do is to count the individual nucleotides. So let's just say we have our DNA-seq here. I'll also define it again. We want to count the number of A's in it. I'll just do it again here. Let's recreate it. We have ATC, JACTA. All right. So let's just say you want to count the number of A's. And it's A. You can just say A counts. Or let's do it this way. So the function is str count. Okay, so this function can be found here in the string R package. That's why we have to install it. So please make sure to install string R package so that you can have access to the str count. All right, the string count. So I repeat, please install using this command to install the library and then load it. Okay, I repeat, install the string R package and then load it. And then once you've loaded it, you can have access to the str count package. So to count, let's say for example, A. So you have str count, you bring from where, or let's say from which variable or from which sequence do we have to count. So it's DNA-seq. And then what are we counting? That's A. Okay, so what are we counting from where we are counting from? Okay, so we have it like this, and then we run it. So we get 3. Okay, so here we have 3 A's, 1, 2, 3, right? Now you can assign the whole operation to a variable. So you can say A counts We say SCR counts. We say DNA-seq. We say A. Let's use double quotes. Single quotes also fine, by the way. So we have it like this. So let's run it. So now we have it in a variable, and you can make reference later on. If I say print A count, perfect, I have it there. All right. So that's what we have. That's the power of programming. All right. So if you have a long sequence, it becomes difficult trying to do the analysis manually. So that's where programming comes in handy. So with programming, R, Python, Java, whichever, you're able to write codes like this that are able to take your data and then analyze it for you, and then you can get your outputs and submit your reports. Okay, so that is what we are doing here. So as a beginner, please try to follow the tutorial and try to make some notes as well, and then we can proceed. For those who want to support, there's a link that you can use to also buy me a coffee. So check the description box, you'll find the link there. Okay, so let's proceed. Now let's look at the other data type, which is logical. Okay, so with logical, we have two values, true and then false. So you can have either true or either false. Let's look at an example. Let's say bool value, or let's say logical. Okay, let's say logical value. So it can be true like this. Now in R, true can also be written as this. Let's say logical value true. Can also say T. So any of them is correct. All right, so let's run them. All right. Now if I say class logical value, I see it there. Okay. For false, so it's the same thing. So it's false. Let's see. Logical value 3 is false or F. So any of them still works fine for you. All right. So that's it. Okay. That's for logical. Now with logical, you can also ask some questions, and then what will return to you is a logical value. All right. So for example, we have A count. We counted the number of A's. It's 3. If I say A is less than 10, okay, this is an object, it's not found. Good. So because we have not defined this variable, it's not there. All right. If I say A counts is less than 10, then I'll get true. All right. So you notice that here. So in programming, the same thing, garbage in, garbage out. If the variable does not exist, then you get an error like I did. If it exists, then the result will be returned to you. So A count is truly less than 10. That's why it's true. If I said A count is greater than 10, it's false, because we know that 3 is never greater than 10. Okay, so here I'm making a statement that 3 is greater than 10, but it's not true. It's false. So that's why we have false here. This one is a true statement. So we have to. So these are logical. Okay, so you can give some commands, and then the outputs are going to be logical values. So that's what you need to also take note of here. All right. Now we are going. It's getting interesting. So let's proceed. Now let's also take a look at something else here. We will now look at another data type, which is vector. Or you can also say vectors, that's fine. Any of them is fine. All right. Now, vectors are a list of variables of the same type, right? So that means that in a vector, you can have several characters or several logical values, or let's say several numbers in it. It's more like, let's put it as a container. Okay. So let's take, for example, let's say you have an orange. An orange is a data type, or it's a fruit. So if let's say you have a basket full of oranges, all right, that becomes a vector because you have several of that same data type there. Okay, oranges. The basket is full of oranges, so that's kind of how I was playing a vector. So a vector is a list of variables of the same type, a list of values of the same data type. So that's how it is. So let's look at some examples here. I think that will help us get the full picture. So let's say we have, let's say, num vector. So for vectors, if you are adding more than one, so we say C brackets, and you can put 1, 2, 3. So let's run it. So now we have it this way. So here, if I say class num vector, it tells me it's numeric because I have several numeric values in it, but it's a vector. That's what you need to. So it's a vector because we now have several items in it. So if you want to check how many items are there, you can just say length vector. That will give you 8. So we have 3. Okay. So because it's more than 1, it becomes a vector because it's now a container. Okay, so this is the number vector. We have 3 items in it. It's 3. Okay. Now let's also look at car vector, the same thing. So here, let's say ATC, let's say JJA. Okay. Let's just put this to, or let's add more. Let's see, let's add something else. Okay, so we have something like this. Okay, so we have it in triplets. Of course, we could have changed the T to U to get us codon, but at least we get a gist. All right, so this is also a vector. Okay, if I just say length car vector, I have 4. That's what I have here. Now let's try this. If let's say I should say n car vector, let's see what happens. It tells you what? 3, 3, 3, 3. So n car, that means it's picking each of the characters and it will give you the length. So we have 3, 3, 3. So instead we have 4 items which are of the character data type, and then each of them, the length is 3. Okay, but if you want the length of the vector itself, how many items are there? That one, it's 4. We have 1, 2, 3, 4. So that is for character vector. Now for each of these data types, I have some detailed videos on them. Some of them too, I'm currently working on them, which we pick them and then go into details for that data type. So if you want to read more about these data types, just check the description box for links that highlight each of them individually. So those are separate videos. There's an introductory video, and so we are taking it very simple, slow. We can also do same for logical vector. I think I'll put some comments here. This numeric vector. This is character vector. We also have logical vector. So of course, with logical vector, you know what to expect. So we have what? 2, F, cos. Yeah, we can do something like this. So again, if you do class, logical vector, we have logical. All right, so that is what we have here. So it's actually very, very simple and interesting as well. Okay, now let's proceed. Now there's another data type which we call lists. Lists, all right. So list is also, let's say, container. Okay, but the difference between a list and a vector is that in list you can put several data types together. You can have character, you can have numeric, you can have logical, etc. So that's the difference. All right. Okay. So let's even do this. Let's try this first before we proceed. So let's make sure everything is in order. All right. Now for lists, if you want to create this, you add the word lists. Okay. So let's say lists. Okay. Let's say lists. Example. So for lists, you say lists. That's the word. And then you can bring your items in it. So here I made mention with a list, you can put in several data types, or let's say different data types. So I can say car vector, I can add that. I can add logical vector. All right. I can also add numeric vector. Let's see if I had it there. That's num vector. Let's do this here. Num vector. All right. So let's run it. So I have it there. Now if I say class list example, I have the list. If I type list example, you have the items there. Okay. So you have them here. Now with lists, okay, you can do something like this. Let me just show you. Not just lists, but with characters as well, the vectors. Let me put it that way. You can do what's called indexing, where you select a specific part. Okay. Now we know that if let's say I do length, let's example. I have 3. Okay, because we have 3 items in it. If let's say I want the first item, let me just use this word indexing. I can say let's example 1. I'll get it there. Okay, now in R, counting starts from 1, unlike languages like Python where counting starts from 0. In R, counting starts from 1. So if I want the first item or the first element, I have to use 1. Okay, so take note of that. Now that's indexing. So I can do for the list. If let's say, let's look at the car vector. Let's say 1. I also have it there. So for vectors 2, you can also use that indexing. So 1 or 2 or 3, depend on which you want. Okay, you can also do for more. Let's say if you want 1 to 10, it's also possible to do, but those are things we'll cover in detail in other videos. All right, so take note of that. So that is for list. Now let's also look at data frame. I believe this is something that if you are doing analysis, you always come across. So we are also going to look at that as well. So for data frame, let's create one. We can say data.frame. Then we will specify our columns. So let's say numeric. Or let me just use uppercase numeric. It will be equals to num vector. Let's add something else. So here, okay, yeah, num vector was 1, 2, 3. Let's see, yeah, this one. Okay, so with data types, I'll rather shift to this one. I'll shift to these ones. Yeah, if you are creating data frames from your variables, then you need to make sure they are of the same length for the most part. There are ways to go around, but at least to be safe as a beginner, make sure they are of the same length, right? So here I'm going to do this. I'm going to recreate things I will use in it. Okay, so I'll do this. for data frame, you need your columns. So that means you need to have your values ready. So I'll just do this. I'll just do the car vector again. Okay, let's see. This time I'll say A, B, agent, C, and use 4. So that's the car vector. Now here it says A will not find function. Why? Because if I'm creating a vector, I don't have to use A. I have to use C. Okay, so this command will give me an error, but if I use C, then I'm going to get the right answer. Right, so sometimes you may make mistakes, but you need to go back and check and make sure you are using the right syntax. All right, so that's what you need to know. Now, when we come to numeric, or let's say num-vector, let's say 1, 2, 3, 4. I have that also done. Let's say logical vector C, T, F, T. Okay. Here again, I get an error because the C is not there. And so I have to bring the C. Sometimes when you are typing, you may have some typos. So when you see them, just check, then do the needful. It will be fine. All right, so you do it, you have it there. So now I can create my data frame. So I'll say df, then I'll say data.frame, and I'll define my columns. So I'll say numeric equals num-vector. Then I'll say logical equals logical vector. Then I can say character equals char vec. So now I'll execute this command. Perfect, it's done. So now I have my data frame. If I say class df, it will tell me data.frame. Of course, since it's data.frame, data, that's df. Okay. I can just print it like I did. I can also print it this way. Let me now use the cursor. I have it here. So you see, with data frames, you have what? You have your rows and you have your columns. So first column is numeric, second is logical, and third is character. So these are the columns. You know, we define them here. So this is one column, this is another column, this is another column. All right, so this becomes our data frame. Okay, so it's quite interesting when we do some of these things.